Good evening, everyone. Can you please confirm if you can hear me? Just type a yes in the chat box if you can hear me. Awesome. So I know many of you are wondering where can we watch the replay. So I am pasting a link on the sticky note. If you click the link, it will lead us to our YouTube channel. There you can actually watch all the replay videos. So let me put it in the chat as well. Sharath and Barney would be joining us shortly. So before they join, I just wanted to walk you through the process. So what we are going to do is I'm going to share my screen and then I am going to show you the playlist. So on the sticky note, you will find a link which says bit.ly/NLP hyphen 360 digit MG. All you need to do is click on the link and it will take you to a playlist. Right here. It will open a playlist which has all the 4 videos. So day 1, day 2, day 3, and day 4. Day 4 is what's currently happening, so it's already added there. And if you wanna, after the session, if you would like to go ahead and watch the video later on, you could simply do that. So let me quickly ask you guys if it is clear. All right. So please answer the poll question if you've understood how to access or how to watch the replay videos. Awesome. I guess most of you understood it, and I believe Sharath is live. Sharath, can you confirm?
Yes, I'm here. I'm here, Enoch.
Awesome. Over to you, Sharath.
Hey, thank you. Thank you, Enoch. All right, friends. So let me start discussing about today's session. We will be starting with hands-on from where we have stopped yesterday. We'll continue from there. And then post that, we will be welcoming Bernie, and he would be taking care of LSI and LDA concepts. Topic modeling, basically, he will cover that part today. So let us begin. Do we have still more people to join in? I think, yeah, we still have a lot of people to join in. Anyways, let's begin the session. So today we are going to look at the extraction, web extraction part. Okay, so we will try to look at how we can extract the data from Twitter and any of the HTML web pages, and of course we try to extract data from Amazon as well. So that's the agenda for today in the Python coding part. Now before I start, we actually need Twitter account. If you do not have Twitter account, then you cannot create or you cannot use this particular code. You will not be able to extract it. Simple. So we need to first create a Twitter account. So in order to create the Twitter account, I'm going to twitter.com. This is my account. Okay, every day there is some or the other change that they bring in. All right. Right. So this is my Twitter account, guys. When you're creating, if you do not have Twitter account, as I said, create it. And when you're creating it, make sure in the settings you provide all your details, valid details, so that in future when they validate, you should be able to validate the account. They would be sending your the OTP to your email ID, phone number, so on and so forth. So mandatory thing. Next, once you have created your account, right? For this account, you need to have a developer's account. First is you need to have Twitter account. Then for Twitter, you need to have developer's account. Previously, it used to be called as apps.twitter.com. That's what we have in the code as well. But now it has been changed to developer.twitter.com, if I'm not mistaken. Let me try and do that. Even if I try apps.twitter.com, it would redirect to your developer.twitter.com/apps. That's the website. Now, you need to log into your credentials, Twitter credentials, and then create this developer's account. Initially, you will not have this. They will ask you to provide justifications and all that. You have to provide all that. It might take, they say that it might take 48 hours to validate your account and provide you the developer's account. But generally, it is done immediately if you provide proper justification. Generally, I always keep saying that it might take 24 hours to get the account, average. Make sure you have this developer's account, and then you come to this page. You see here under your dashboard or developers page, you have create an app option. You would have to create this app. I click on details. This is what I have. Right, so let me show you how to create this. Click on create an app. Provide a name here. There are required fields. Provide a name. I'll say XYZ. Give any justification to test the extraction using Python. You want to test the extraction code using Python. Then website, you can either give 360-digit ng or InnoDataTix, whatever you are associated with, that will also work. Some URL or something, you have to provide that. And then, yeah, these are not mandatory. Here you have to give minimum 100 characters to create the application. You have to explain. Learning Python, or learning NLP using Python. Working on extraction of data from Twitter. This is part of the text mining and NLP learning. Some 100 words, and then create. You create. It will say basically all these information. It will ask all this information and just say create. App name, yeah, it's already used. This name is in use already, so you can say share 2020 NLP. Some name. Hopefully this is not already taken. Create. Wonderful. So once you create the developer's application, right? This is one application that you have created, okay? These are all the things that you have given. These are the permissions. You have read-write permission and additional permissions are not there. If you want to give additional permissions, you click on edit and provide those permissions, okay? The important thing that you need to take in from this application that you have developed is the tokens here, the keys. These are encrypted keys which allows you to log into your or use your Twitter account for extraction. So here, consumer API keys are there. Copy paste these things, save them. Okay. And here this is the fresh account, right? This is a fresh application that I've generated. So it doesn't have access tokens. You need to generate them. Once you generate them, from the next time onwards, if you feel that you want new tokens, you can click on something like regenerate button would be there here. You can click on that. So let me click on generate. You have to copy these keys and save them. These are encrypted keys. So it basically talks about your user identity and what kind of permissions you have, right, that you can basically perform using your Twitter account to access what kind of access permissions you have. So these are the tokens. Make sure you're saving them. So you can see regenerate, right? If you want to copy them, you can again say regenerate and you get these things. You have to save them, very carefully save them. But yeah, even if you lose it, you can regenerate every time. That's okay. Save these 4 keys: consumer API key, consumer secret key, access token keys, and access token secret key. We will be using these 4 to connect to Twitter account using Python. All right. Now, once you have created your Twitter account, developer's account, and you have created an application and copied those 4 files, 4 keys, we will be using these 4 keys, okay? Once you save those 4 keys, for extracting data from Twitter, in Python, we have TweePy. Pip install TweePy. If this package is not already installed, then we need to install this. Pip install TweePy. Then we will be loading pandas, importing the TweePy, and from the TweePy, you have something called as OAuth handler. OAuth handler is a authentication validating function. So you are going to pass these credentials, and OAuth handler is going to verify and give you connection between Python and Twitter account. So it's basically an authenticator. It validates your account and connects to Twitter. Right. So once you have loaded, we will define these 4 keys: consumer key, consumer secret key, access token, secret key. Right? So load these 4 keys. Next, we are calling the API, the Twitter API. So we say auth tweepy.oauth handler. We just imported that one right here. So we are importing, we are calling that, and we are passing consumer key and consumer secret key. This is like your username and password. How do you get access to your Twitter account? You'll have credentials, right? Username, password would be there. And using username, password, you log into your account, right? That's exactly what we are doing here. So you're defining your credentials and calling that as auth, authentication. Next, once you connect to your account, what kind of access permissions you have? You have to pass those access tokens as well. So you're defining your auth, that is authentication, and you're calling that as API. You define what you will be doing with Twitter. API is equals to tweepie.api auth. Then we have multiple functions that are possible under TweetPie. We can do a lot of transactions, a lot of things in Twitter. We will be looking at how do we extract data. Even that extraction of the data can be done in generic way. So I'm going to use a keyword called Python. I'm defining the keyword as Python. And I'm searching for that keyword. API.search. And here I want to capture 30 records, 30 statuses. In Twitter, we call them as status. Twitter message that you're seeing, right? That's called as status. You don't want any retweets. I'm tweeting it, somebody's retweeting it, right? On my page or on that particular tweet, somebody is writing something. Again, you're writing something. So those kind of retweets I don't want. So you're saying exclude. And tweet mode is extended. A lot of details will be captured. Extended details will be also captured. So API is nothing but these authentications definition that you are basically given to your connection. Using that, you're searching for the keyword. And the rest of the arguments are also there. When you do this, it has extracted tweets, your statuses into tweets keyword. Now this tweets keyword, here, is in this format. You cannot read the content directly like this. This is what you'll see. Right? So in order to look into the content, we would use this for loop, and we want to see only item, text part. For item, in tweets keyword, print item. That means take that text keywords and print each Twitter status separately. This is what you get. You're writing for loop so that you get all the 30 tweets. A lot of details are captured. Okay, it's not just the tweets that you'll see. Yeah. This is your first tweet, which basically has Python name in it. When did it got posted? Today. Midday, around 2 p.m., 3 p.m., close to 3 p.m. The full text is linear transformation, linear algebra. The origin doesn't change, nor the lines bend and do remain parallel. Somebody on my wall has posted something about the content, linear algebra content. So it has captured that, and somewhere here you will have Python coming into the picture. I'm just trying to find out if I can locate that Python word. Look at that. Here it is. Right? So this is how your search is done. Very simple. Twitter allows to download the data, but not all will do that. Okay, don't try to download data from all the social media platforms. Not all will allow you. In fact, all of them have shut their doors. You will not be able to do it. Now, this is one way to search the generic keywords in my entire page. But how about extracting data from a specific personality or a specific service, or I want to capture the data about a politician, a person, right? A person, a thing, a service, product, could be anything. You want to capture the data from that particular wall. So you will use user timeline. This is the function, user timeline. Now for this user timeline, of course, it is from VPy package. If I search, I'm searching for this result. It's not showing information. It's not showing. Okay, we'll do one thing. What is coming? No, it's not showing like this. We can go to Google and search for the various applications that you can do. So let me try and explain here. PyPy Python documentation. Right? PyPy is a library. This is where you have the documentation. So these are all various applications that you can do for PyPy. And if I come down here, these are all the things. Status lookup, home timeline, user timeline, retweets of me, get status, update status. You can also update your status using Python code, okay? All these experimentations can be done, okay? Now we are using user timeline. By default, it returns 20 most recent statuses posted from the authenticating user or any other user that you specify. Okay, so here the screen name would be the user ID name in Twitter. So here I'm trying to extract Sachin Tendulkar in Twitter, but let's say I'll try to do it for Sehwag. Not sure. I'm a big fan of this guy. Yeah, he does wonderful tweets. Look at that. Welcome cocacart.in. So he does marketing for products. He gets paid for that. Okay. So these are all different posts that he has made. Okay. Now we will try and extract data from him, his profile. Right. So let's do it. So rather than Tendulkar, let's try do this. You can do it for any user. I'll just change it to Vijay Sehwag. And I want to extract 200 tweets, or let me take, let's do 200 tweets. That's it. You just have to pass the count and the screen name. Job done. So it has captured 200 tweets. You can see here. Result set is 200. Again, you'll not be able to see each and every result like this. It's not in a readable format. So we will be printing each one of it, but 200 tweets are there. If you print it, your console, you'll not be able to read all of that, right? So what we do is to save. We save this data, right? So let me try and save this data. Tweet.text for tweet in tweets underscore user. So you have saved everything in this tweets underscore user, right? So you're taking text data from that particular tweet. Each and every tweet that you get, take text part from that. You don't need all the information. And convert that into a list. You're saving that as a list. This is list. You have the tweets in a readable format now. Yeah. So you have 199 tweets from 0 to 199. So 200 tweets have been extracted. Oops, 200 tweets have been extracted. But this is still in list format in Python memory. We want to save that into a physical file. So we will first convert this list into a data frame using pd.dataframe function. And for the column, you're giving a name as value. You're right, saying that, hey, this pd.dataframe that you want to create is for this particular list, and the column is this. Right? So capture this. That's what we are doing. pd.dataframe. Now, once you have data frame created, I can save this data frame directly into a CSV file. So in order to do that, we will use to_CSV function. Very easy. You just say data frame dot to_CSV, to_CSV, and give the physical file name tweets.csv. I've done that. Now this file that you have created has to be written onto your hard disk, into your system. But where did it get written? You have written it somewhere, but where is that? So in order to identify the location, we say import OS. Right? This is a function, library, and OS is a library. In that library, we have get CWD. If you do get CWD, you get the working directory where the file is getting created. Let me create that. And yeah, I'll go to users. I go to this folder, and this is the file. 23rd July, 8:27 p.m. Just now it got created. You might want to open that and see. So you have the text data now, right? You have successfully extracted data from Twitter. Now you perform a lot of analysis. You can do a lot of analysis on this particular data, right? So you can tokenize this data, then you can try and understand the named entities. Then you can also do sentiment analysis, what kind of polarity each word has, whether Sehwag is speaking always positive words or negative words. So all these analysis can be done. And this is exactly what Avinash has done. Who is Avinash? Anyone is familiar what I'm trying to talk about? Avinash is a person who is by profession a data scientist, and he was the person who was responsible for helping out Trump's victory. He helped Trump to victory. Avinash Hiragavarapu. His name is this. This guy. Yeah, he has a page as a Wikipedia page. He became so famous. Look at that. He's a political campaign strategist and was also executive director of Arizona. You might want to read more about this person, this gentleman. Yeah, he's changed, I guess, a lot. Yeah, he changed a lot. Yeah, he is basically pursued MBA from IIM Lucknow, and his inclination toward politics has lured him to do a lot of analytics and help Trump. Right, you can read about this personality later. But what he has done is called as sentiment analysis. You will be eventually learning that also. And yeah, that's the data extractor. On top of that, you can do a lot of things. But this is from Twitter. Right? This is not from all the websites. This is just a Twitter page. Now, if you want to extract data from internet on web, you need to understand that the pages are in HTML. Most, right? All the pages that we talk about on internet, they are on HTML pages, right? All right. So if I go to the top of this code, we have a library called Beautiful Soup. Right? This is a function, Beautiful Soup, which is available in a package called BS4. From BS4, import Beautiful Soup. Okay, this package that I'm talking about will help you to scrape the data from HTML pages. When I say HTML pages, you need to try and gain some kind of knowledge on HTML coding as well. Now, that doesn't mean that you have to become a coder, HTML page developer, but you need to understand the style, how the HTML pages are written, right? So let's discuss about that now. Let me clean this off. So I'm importing the package Beautiful Soup, BS4, and that BS4 is giving us a function called Beautiful Soup. And there is a web page with me. I'm trying to bring that up. So I'll be showing you the content. Yeah, this is the sample doc that I have. I'm staying at mess. I'm not sure. Mess number 72, Banamali, Naskar Lane, Kolkata. And Sherlock stays at 221B, Baker Street, London, UK. Hamlet said to Horatio, there are many things in the heaven and earth, right, etc., etc., etc. So this is some random text data, or I should say HTML content. Now, if you want to understand the HTML style or HTML coding, you just have to right click on this page, right click, and you get this view page source. Click on that, or you can either say Control U or view page source. And this is the HTML code for your page. Now you need to understand that for every bit of the content that we have, there are tags. For example, here you are saying title, and this title is ended here like this, /title. Body, this is the entire body of your page, right? And you are saying this is a HTML. You started it here, HTML, and ending it here, HTML. Right? Let me try and increase the font size. Yeah. So body, I'm saying I'll start here. Then again, sub content or the sub tags are also there. You can see address here. You're passing address, then breaking the line. Then you're saying Sherlock. B is provided here just to keep it different. And you can also see H1, table, TR, TH. So different tags are used. You need to understand these tags, okay? And there are different ways to give the tags. You can define these tags as well. There's no standard process that you should follow. Now I'm loading this particular data, the HTML page, okay? I'm trying to load this HTML page. And here we have html.parser. This is an argument that I'm passing for my Beautiful Soup function, where I'm saying open this file, and then let's parse the content that we have in HTML format. So beautiful soup is a function which does that. So I'm defining it as soup. And if you say text, it will give you the complete text that we have here. Okay, let me show you. You just say soup.text, it extracts the complete text that we have. Printing everything. Tags, no, it will not print tags, but the text it will print. Soup.contents. These are all the different contents that we have, including your tags. Okay, that's the difference between text and contents. All right. Next, if you want to capture a specific content or specific text of your HTML page, then you're going to pass your tags here. So I'll say find address. Always remember, the soup package or a beautiful soup function is looking for key value pair. Any analysis that we try to talk about, right? It is always key and value pair logic. So here the key is address, which is nothing but the HTML tag. And then the value is nothing but the content or the text that we have with respect to this particular address. So if you see here, when you're saying find, soup.find, it looks into the entire content and sees this address, the first address. And it prints the content which is there between those tags, address tags. So find address. Right? Now you want to get all the addresses, all the content which is there with respect to this particular tag. Then just say find all. When you do this, find all, it prints both the statements. So here you have two sentences or two addresses with the space, mentioned in the HTML page. So it prints all those, right, address tag data. Then you can also say Q. Do we have anywhere Q mentioned? Yes, Q is here. So it prints that part. Yeah. This is your part. There are more things in the heaven and earth, or Horatio, I don't know how to pronounce that, than are dreamt in our or in your philosophy. Right? So yeah. Then identify all the tags with the name B. So what all things that we have with the tag B? Sherlock, Hamlet, right? Horio. So these are the tags, or these are the content with the tags B. Okay, next we can also extract table. So if you see table, this is the cut. Oops. Okay. Yeah. So this is the table output. This is the second part, you can say. Here the table is there, right? So it's capturing the table part. You can also do find all tr. So this is tr, this is the content. So if you say find tr, then it is, right, just trying to capture within the table that you have captured now. In that table, you're trying to find out tr, right? And you're creating columns. Basically, you're giving a structure to that content that you have extracted. Each row, each column, right? That's how it looks like. And if you want to find a specific value in this particular list, it is a list now. If you observe, it is a list now. You are saying find all values with the tag tr. right? We are capturing all the tags with all the words with TR. Okay, in this part, capture everything which is there with the TR. And then find all TD. So first take third TR. So this is the first TR, qualification, addition, qualification. The second TR, the third TR. So if you look at this, this is the first TR, second TR, third TR, so on and so forth. Right? This is the third. So this is your third TR. All right. And from this TR, capture all the values which are there with the tag TD. From that, capture the second value. Second value means it becomes third one, right? So 0, 1, 2. So it should give us the result as MTech. Yes, look at that. It is giving us the result as MTech. Right? So this is how we extract the data from HTML pages. Right? Now let me show you how do we extract data from Amazon using this beautiful soup library. Right? So let us import requests from BS4, beautiful soup. I'm giving a short name as BS. And RE is to handle the strings. Regular expression. So we will be looking into the word clouds and all that later. Let me first show you the extraction code. So what we're trying to do here is, let's say you want to purchase a phone, friends, or any product in Amazon. What we do, we open Amazon, search for the product, and the search results that you are going to get, the search results that you are getting, right? Out of those search results, you select the product, one product that you want to purchase, and directly go and make the purchase. Do it this way. Do you do this way? No, right? Before you want to purchase a product, obviously you want to do a research. Study about the product, and that study is nothing but ratings and reviews. Reviews is more important. Rating is basically talking about the product's performance with respect to all the users who consumed it on a numeric scale, 1 to 5 scale. But you want to understand whether a specific feature of the product is good or bad, or what all those features that this product is famous for. If you can understand that, then probably you will be taking a decision, wise decision on whether to invest on the product or not. Right? But let's say you want to purchase a product like this. Let me show you the product. Assume you want to purchase a product. So I'm selecting this URL. Let me show you that. Oh, I did not copy this. Okay, let me copy it. So this is a product. OnePlus 7 Pro. I want to purchase it. But before you want to purchase it, you would look into the reviews. So let me go to the ratings here. These are the customer reviews. If you scroll down, these are all the reviews. And here, if you click on see all customer reviews, it will take you to this page, all reviews. Right? But yeah, we are not focusing only on the first page. It doesn't give you all the 2000, not 2000. How many are there? 22,000 reviews. It doesn't show everything in the one page. Amazon has the standard. They follow the standard where they keep 10 reviews in each page. Now, when I clicked on second there, it was showing the page number as 2. Change the page number to 2. And it was showing 11 to 20 reviews. Okay. So if I go back, this is the first page. 1 to 10 reviews of 14,029 reviews. Not all the reviews I'm looking at, okay? Sorted by top rated, all reviews, all stars, all formats, text and images and all that, okay? So this is your bifurcation and this is your comment. I want to extract this part. And then we will be developing word cloud. Yesterday we have seen word cloud, right? So analyzing the data for 14,000 reviews would not be easy. Manually cannot do it. So we will extract all these reviews and create the DTM using bag of words. We have created bag of words, right? Did we do that? I'm assuming we have done bag of words yesterday. Please confirm, friends. Count vectorizer, TF, IDF vectorizer. You have done, right? Wonderful. Yes. Let me see the answers. Okay. We have done that. I'll take your questions, friends. Yeah, hold on. Let me complete this and then I'll take your questions. So once we get the data, we tokenize the data, cleanse it, generate bag of words for each document, and apply that same logic for entire text data. So we get TF-IDF, count vectorizer, which gives us DTM or TDM. And using this DTM, we'll come up with the word cloud, right? So that's the application here. We'll first extract the reviews, then perform this, generate word cloud, and then make the inferences, right? So let us try and do this. We'll only see the extraction part now. So this is a HTML page, remember that. Okay, so I'll right click on the page and say view page source. For every HTML page, you can do this. Okay, this is your HTML page for your entire Amazon 10 reviews data that we are seeing here. Okay, very big, right? HTML content. Now we are not interested in everything, not the entire page, not interested. I want to get to this. So let me search for that particular review. This is a title, so we'll not look into this. I want to go to the body of the review. This is the body. This is the review text. So for that particular text here, what you are seeing, you have a class. For every review, you will start with this particular tag only, the class. Using this class, you will try to extract the data. So for every HTML page, right, you need to understand that class. What is the tag from which you need to capture the data? So for here, we are understanding that I need the tag th. I will be extracting the information which is put inside that th or b or address, right? So Amazon has come up with this particular tag. It says a size-based review text content. This is the review body, right? So whatever we have done in the previous case in a standalone way, we are now doing the same thing onto the multiple pages. So first define an empty list here. 1 plus reviews, and it's an empty list, 0 content is there. Then I have to pass multiple pages. If you want to extract from one page, you can directly do what we have done here in extracting. You just read that content and then you can do that one page. But if you want to extract multiple pages, then we have to do this for loop. Right? Range of 1 to 21. That means we are taking 20 pages. Remember Python, n minus 1 would be treated in the upper limit. So we have for loop in range of 1 to 21. Again, inside this loop, I am creating another list, empty list. And this list will be reading the individual review. Remember, we said there will be 10 reviews for each page. Right? So individual reviews will be stored here. And we will be having 10 reviews for each page. Okay? For that reason, we have defined this. Then for that multiple pages iteration, right? We take the URL here and paste only till equal to. Here, if you observe, only till equal to, sorry, only till equal to is taken. That page number is passed as a string to this particular value. Where I is the counter, I will take values from 1 till 20, 1 to 20. And yeah, we are adding all that to URL. By converting that into a string, we are creating a URL. First, I is equals to 1. You get one URL, page number 1. Then you are defining this response.get URL. Response is a package which is basically helping us to scrape HTTP data. Web scraping is possible because of that library requests. It is basically understanding the internet data, HTTP data. Right? Next, beautiful soup. Pass the content. This is the URL, right? Take the content, right? In the HTML, basically you do the parsing, HTML parsing, and capture the content, right? And we are calling that output as soup. Then from the soup, you want to find all the iterations of that particular tag, a size-based review text, right? And then store those things into IP. So this review is one review at a time. It is basically storing 10 reviews that we collect. Find all is going to capture 10 reviews, right? So it's going to store in reviews, but it is not in a human readable format. So you're converting that into a list and storing it into IP. And that reviews from each page are getting stored here into 1 plus underscore reviews. Annotation is very important. So this is your for loop, which is going to extract your data. Now, mind you, there is a problem with the beautiful soup and Anaconda. Of late, Anaconda has changed something. Not sure what. We are yet to figure out. I have to yet to figure out. The point is, it's not able to extract everything. 20 pages into 10 reviews, it should give you how much? 200 reviews, right? It's not capturing all the 200 reviews, unfortunately. I tried multiple times, and every time you execute, you might get a different set of values. So if I flush it and try to execute it again, you might get a different number now. You may get same, you may get different. It could be because of the internet speeds, the timeline speeds, or something, right? But using Python library, we are not able to extract complete data from Amazon. Anyways, but we still have 120 reviews extracted. This is the data, right? Now this data, I want to save it. So you can basically save it like this as well. You don't have to save it in a data frame format. You can always do it using open function. Here you are writing into that file. You're creating a file called oneplus.txt and writing the content in UTF-8 universal character set format, right? And this is you're saying as output and output dot write. When you execute this, the file gets created. And this file is again going and sitting in the this location, standard location, working directory. You can see this. These are the reviews that we have extracted. Now, once you have data, you can perform a lot of analysis on top of it. All right. So this is web extraction, friends. This is how you extract the data. Now let me take your questions. Yeah, Shantanu, I'm going to load it tonight. I'm going to get it updated today. What keynote, Sarabjit? What keynote you're talking about? Yeah, all the files till now. I'll get it uploaded, Shantanu. Where I have applied for Twitter account in the morning for, yeah, that's a challenge, Rishikesh. The justification you have provided may not be right appealing to them, so that they will take some more time to provide you the access. But you have provided the right justification for your developer's account, it will generally be done in within no time. We have given the count as 200, right? Yes, Shruti. So that would capture the 200 tweets from that particular page. So we have extracted Virendra Sehwag's tweets, right? 200 top 200 tweets are getting extracted. All right. All right. Any questions? Any more questions? Anyone? Okay.
Sharath, maybe we can. Are you able to hear me?
Yeah, Bernie, but it's very
Yeah,
low.
I just logged in. Maybe
Ah.
we can give 10 minutes break and then I can get started.
Yeah. I was just waiting for you, Bernie. Sure.
Okay.
All right, friends. So, yeah. We'll take the break now. Connect back in 10 minutes. So yeah, 9 or 9:10 we will resume. Okay. Yeah, connect back in 10 minutes, friends.
So, let's see what kind of questions you have. Not lost connection, we had break until now. Okay, I can see only a few, as you can see. Please put word cloud Sehwag tweet in Hindi to English. Yep, you can try out. Absolutely, Siddharth. I think. Okay. All right, guys. So let me tell you that, and I'm going to also request you all on this, that on Saturday and Sunday, also we are going to have the session from 7 to 9 a.m. Okay, not p.m. Absolutely not p.m. This is an additional effort we are taking. So I request you all to stretch a bit. 7 a.m. to 9 a.m. IST, we'll be having classes. Not just tomorrow, but on Saturday and Sunday as well, because the schedule got extended. We thought 3 days. It's taking now what? 1, 2, 3, 4, 5, 6, 7 days. 4 additional days is what we are investing, and we are just expecting you all to wake up a little early and attend the session. Would this be okay to you all? It should be okay, right? All right. Another thing is, are you guys really able to hear me? Okay. Wonderful. Code, we are putting that on YouTube channel. You can pick it from there. You can see and type it, because that is how you learn. All right, wonderful. Let me move on then. So you guys have learned about NLP pipeline building. Pipeline building means it is all about establishing the tokenization, stemming, feature extraction, term frequency, inverse document frequency, matrix generation, model building. All these things can be automated. And you know for a fact that data cleansing and pre-processing would take significant amount of time, right? It will take 60 to 80% of time. Since it is going to take 60 to 80% of the time, it can be automated, and that is exactly what we have done for our clients, right? So we automated this entire process of data cleansing and preparation. That saves significant time. All right. Pipeline is all about creating an ordered list of all these stages. Code modularization is so much important. Okay. So you do all of that. You save your model on a hard disk using JobLib or Pickle library. And then whenever you need, whenever you want to use the model, you just load the model from the hard disk to the memory. Tokenization, stemming, feature extraction, model building, saving and loading the model. This is a pipeline, and this is exactly what you're going to learn as part of our live projects, right? When you guys work on the live projects, of course, the participants who have enrolled with us, you learn about modularization. How do you do this? How do you automate it? How do you condense the duration of the project? Okay, next. Shaping the web pages is one big thing. As part of data collection, you need to do that. Different websites have different ways of providing you with access to data. A few of the websites do not even allow you to scrape. How do you find out? Experiment, try. If it doesn't allow, that means they have restricted, right? Okay. Web page can be written using HTML or PHP or Java or .NET or any other framework. HTML stands for Hypertext Markup Language. A markup language is one in which text content is embedded in between the tags. Additional information can be added by using attributes within the tags. Here we go, the tags. I need to make even a few more changes, I believe. Huh? What happened? Why is it not allowing me select this? Yep. So here, this entire stuff that you're seeing here is called as element. This entire stuff is called as opening tag. And this is your closing tag. That's the opening tag. This is a closing tag. Anywhere in between that is a content that you want to extract. This is the attribute value. This is the attribute name. This is about HTML. Sometimes you might have data in JSON format. JavaScript object notation files are used for storing and exchanging data. And as part of our training, as part of R and Python programming, you would have learned about handling different data sets such as JSON files. If not, then that should be included and will be included from our side. And second thing is, when you work on real world projects, customer will not always download the data and give the data to you in JSON format or XML format or in any other format. Rather, customer would say, hey, here is my database, which has a lot of tables within that. Go establish the connection with Python or R and pull the relevant data and proceed further with your analysis. In a, of course, secure environment, probably using VPN or something you connect, or using RSA tokens you connect, and then securely you pull the data and then process the data, and then write back your results to the database. If this is not, this wasn't part of your training as part of Python and R programming, then we are going to certainly include this module as part of your live projects. Okay, next. We have NoSQL databases such as MongoDB, Cassandra, so on and so forth, which also stores the data in the form of JSON objects. Okay, JavaScript object notation. And then XML stands for Extensible Markup Language. Here you have the liberty to use your own tags, and then sometimes you might also end up extracting the data from XML. Then we have topic discovery. What is this topic discovery all about? And how is it going to help? Okay. The first thing is, topic modeling. Topic modeling or topic discovery, I'll get there. First of all, topic modeling. It is a popular concept of natural language processing. It is all about collecting the interesting information and meaning from the collection of documents. Okay. And if I give you a specific document, for example, or an article or a blog or some social media comments, and if you are expected to extract the data from this, how would you do that? Right? You do that using topic modeling. As a CEO of a company, maybe you are working for 16 hours, but at the same time, the market is demanding. People expect you to keep yourself abreast of all the latest happenings, all the latest news, whilst working for 16 hours. That is tedious and very demanding. So if I can use topic discovery, interesting topics can be extracted from this and it can be summarized in 2 to 3 lines or 4 lines. And then you have the gist of the entire news. You can take the entire news channel of the day, perform, some kind of topic modeling and discover interesting topics. There you go. You have the gist if you do not have ample time. This is exactly what happens even when it comes to legal documents. There'll be multiple documents, many documents that you'll have to handle. Reading all these documents and taking an informed decision by the judiciary would be a tedious task. Can we actually do this analysis, give a gist to the judge so that they might take informed decisions? Oh, yes, absolutely. And this topic modeling and topic discovery is an unsupervised learning technique. Even Sharath, for that case, has extensively worked on this project for a client called as SKP Group, which is an accounting firm with they have a lot of chartered accountants with decades of experience. So the project was that you analyze the entire document and can you give me the gist on which industry this document belongs to? Does it belong to retail, or to which industry does that actually belong to? Okay, so themes or topics would be available in the documents. Document could be a single tweet, or it can be a single review, or it could be a single news article. Anything can be document. Okay, and collection of all these, I mean, if you have 10 tweets or 100 tweets or 1,000 reviews or 100 news articles, collection of all these is called as corpus. Okay, so themes can be used to classify the documents. So okay, and another project I can briefly speak about here is the project that we have done for a US client, which is specialized in educational loan. So you take all the documents. I mean, here when I say document, I'm speaking about the loan application form. And you get all the details such as what is the age based on date of birth. Did someone make any change? Okay. All right. So here, age, gender, so on and so forth. And then this particular financial services client, that do you know what? When students apply for loan, they usually apply the loan for the very first time in their life. If they're applying for the loan for the very first time in their life, then we really are not sure about what is their credit history. So we cannot predict on whether they are going to default on the loan or not. Can you use data which is available on social media to extract the data and then probably come up with some emotions? Or can you also extract information on what topic are they really focusing upon? Is it related to racism? Or is it related to some kind of politics? Or is it related to some kind of posts about international holidays always? or always buying latest of the gadgets? Would that give me another topic saying that this guy is a spendthrift? He spends a lot. So would that student really have the money to repay the loan? Right? So those are the kind of projects we have worked upon. It might sound very peculiar, and yes, that is exactly what we do. All right. It will not be the regular run of the mill. At every point of time, you will find something interesting and something new. Okay. So even in forensic analysis, topic modeling is used to discover the themes in online text sources. Because when it comes to forensic analysis, you need to resort to your social media and research to a very great extent. Now, people also extract a lot of data from Wikipedia to know about a lot of facts about the world, right? Legal discovery and all these things. And then you have exploratory data analysis, which is extremely important. And in natural language processing also, that is very important. And this exploratory data analysis can be achieved using something called as LDA, exploring on what is there in the documents. Which documents can be grouped together? Which documents are statistically similar to each other? Are you getting the data from disparate systems, or are you getting the data from uniform data sources? Right? Many interesting things can be done. And then you also have document clustering. You can cluster the documents based on the maybe the information which is provided in the documents could be related to the buying habits from social media when you extract, right? So on and so forth. And then when you cluster, there are two ways of clustering. One is called as hard clustering, wherein each document or each review or each tweet will belong to only one cluster. And soft clustering means each document, each review, or each tweet can be associated with more than one topic. Okay. And this can also serve as a dimensionality reduction technique. How is something that we are going to discuss as part of the next topic, which is called as latent semantic analysis. There are two algorithms that we're going to discuss. One is called as LSA, which is also known as LSI, latent semantic indexing, which is heavily used in search engine optimization. Our digital marketing team always keeps telling me that, Bharani, we need to have LSI keywords. They just know that. But behind the scenes, what happens is something which we as data scientists know better. Right? And I try explaining them very hard, but then they're like, okay, you just give us LSI keywords. That's it. That is all we want to know. We don't want to know the science behind the scenes. Right? Of course, different people, different objectives. And here we have latent semantic analysis. And we are also going to work on something called as latent directly allocation. We'll learn more about that. Okay, first let us invest some time on this. So this was invented way back in 1980s to index the documents. Today, by default, Microsoft indexes your documents so that when you search, for example, you simply go there and you say, okay, I want to search something called as management. Okay, so it throws a lot of documents. All these are indexed. That is the reason why it is able to quickly get the results out for you. That's an example. The goal of LSA or LSI, both mean the same, is used to uncover the topics that underlie the documents. And what is the meaning of latent? Existing. Something is existing, but it's not, um, you know, it's not uncovered yet. It's hidden somewhere and you're trying to extract that. That is called as latent. Latent meaning is something which is hidden in simple terms, right? Something which is hidden, you're trying to extract. So GenSim library of Python would be used, and it has two classes, LDA, LSI, and you also have coherence model, which is used to measure the accuracy of the data. And then you have terms in the topics. So you need terms to topics matrix. Then you need topic importance matrix. And then you need topics to documents matrix. And there we go. So to understand this, when you have your data can be broken down into U, sigma, V transpose. If at all your data can be arranged in a document format or in a matrix format, this matrix format can be split into U, sigma, V transpose. But to help you understand that, I will have to resort to SVD. Okay. I'm sensing the first image that you have seen there will motivate you all to stay focused. Okay. So we have SVD, which is singular value decomposition. Let us understand now. So even before I proceed there, I wish to quickly explain you about a few mathematical operations which come in handy when we discuss. Okay. So please focus. If I take 1 and 2 as a matrix, and if I say, let me transpose it, what do you think will happen? It becomes 1, 2 in this way. So rows become columns. Simple. If I take 1, 2, 3, 4 and take a transpose of this, it would become rows becomes column in this way. And then if you have 1, 2, 3, 4, 5 and 6, and then if we transpose it, what do you think will happen? Rows will become columns. Rows will become columns. Rows will become columns. And then you have matrix multiplication. If you have two matrices, say you have a matrix which is of 4 by 3, and you want to multiply with another matrix. 4 by 3 means it will have 4 rows, 3 columns. And say you're multiplying it with 3 by 5. 3 rows, 5 columns. When you multiply these two, when these two are the same, then you can multiply these two and then you get AB. And the dimension of the resultant would be 4 by 5. Just because you are able to multiply A with B does not mean you can multiply B with A. That means I cannot do this. Cannot say B is 3 by 5 multiplied with A, which is 4 by 3. The number of columns of this and the number of rows of this do not match. If they do not match, then you cannot perform any operation, multiplication. Okay, you cannot do that. Next, you have matrix inverse. So you take a matrix, you multiply it with, if you multiply both, you get an identity matrix. If you get an identity matrix, identity matrix means you'll have all ones in the diagonal, and off diagonal will all be zeros. If this is the case, then you can say B is equal to right inverse of A, right inverse. Okay, because A into B is not equal to B into A. If B into A equal to I, then A equal to B inverse. So A is equal to right inverse of B, right inverse, left inverse, in that way, right? It's not the same always. Remember that. Okay. Next, these are all very basic matrix algebra. Good to know. And what do you mean by orthogonal matrix? Orthogonal matrix means it has two properties. When you take the transpose of a matrix, multiply it with a matrix, you get inverse. Say I take this example, 2 by 3, 1 by 3, and 2 by 3. Then minus 2 by 3, 2 by 3, 1 by 3. Then you have 1 by 3, 2 by 3, and minus 2 by 3. Orthogonal matrix means if you do a sum product of any two columns. So let's take these two columns. So 2 by 3 into minus 2 by 3 plus 1 by 3 into 2 by 3, that is multiplying this and this, plus multiply these two, 2 by 3 into 1 by 3. When you multiply these, here you have minus, don't forget that. So it'll be minus 4 by 9 plus 2 by 9 plus 2 by 9. Wow, this will get cancelled out, right? This will be 4 by 9 minus 4 by 9, 0. So sum product will always be 0 of any two columns. Take any two columns, it'll be 0. When sum product is 0, what happens is your off diagonal elements will become 0. That's what is the meaning here. And when you take each column, when you square them and add them, okay, when you square these and add these, it'll become 1. So for example, any column. So if you say 2 by 3 whole square plus 1 by 3 whole square plus 2 by 3 whole square, when you square them and add, it become 9 by 9, which is nothing but 1. That's a property. If you have in that way, it's called as orthogonal matrix. Finally, one final thing that I want to explain, and this is something that you'll be hearing every now and then. And remember one thing. This is just a concept which is given this name, eigenvectors and eigenvalues. The concepts that we are going to learn, or what we are learning now, will come in the next slide when we discuss about SVD. Okay, so please pay attention. For any given matrix A, if A into vector V is equal to lambda into vector V, then this V that you see is called as eigenvector of A. It is called as eigenvector. And this lambda is called as eigenvalue. These eigenvectors and eigenvalues come in very handy when you deal with SVD, which is used for dimension reduction. If you have a huge document, you can just compress it significantly. We'll look into that. So let me first give an example to you that if there is a matrix in this way, 200.5. Okay. If there is a matrix A, can I have this kind of a representation? And this eigenvector and eigenvalue can change. It has, I mean, this concept has multiple solutions. Okay, let's see. 0, 0.5. And if I take 1, 0, how do you know you have to take 1, 0? Of course, it is solved using some mathematics. Okay, I'm just giving you an intuition behind this, not the math. Now, if I plot in this way, what happens? Let us understand. I'm saying that this is a vector which is formed by using some math. And this point is 1, 0. 1, 0 means on x-axis 1, on y-axis it is 0. So 0 is anyways origin, this part, 1, 0. Okay. And then if I multiply this with 2, what do you think will happen? This will become 2, this will become 0. So this part will become 2, 0. If you were to plot it again, 2, 0, 1, here you'll have 2, this is 2, 0. So the vector direction did not change. Vector direction did not change. The magnitude by which magnitude changed. Okay, vector magnitude changed. It got increased because you are multiplying it with 2. It got increased because you have multiplied it with 2. But vector direction remains the same. At the same time, if you take this matrix A and then if you multiply it with 0, 1, I told that it can have multiple solutions. So this is equal to 0 into 0. Vector is 0, 1, 0, 1. Okay, if I can have this representation, A into a vector is equal to lambda into another vector, then this is called as eigenvector and this is called as eigenvalue, is what I told. I'm telling that these two concepts are used in SVD and principal component analysis in dimension reduction to a great extent. But you'll have to bear with me until we discuss that. This is just a foundation that I'm laying down now for you guys to understand SVD further. Okay, so please pay attention here. Okay, here 0, 1 means 0 is x, y is 1. So this will be 0, 1. Now if I multiply that with 2, this portion will become 0 and 2, meaning x is 0, y is 2. Here 0, 2. So this is your vector size, this is your vector size. So the size increased, it doubled. It is 0, 1, it became 0, 2. But the direction remains the same. Direction is the same, just the magnitude changes. Vector whose direction does not change is called as eigenvector. Simple. Okay, I can give you another example here. Say I have a vector 1 and 1. If I have a vector 1 and 1, then what happens? 1 comma 1 would be 1 here, 1 here. It'll be somewhere here. This will be the vector. And if you're multiplying that with 2, it will become 2 and 2. 2 and 2 will be where? 2 here, 2 here. Okay. So kind of the direction changes basically. Okay. Or let me put 0. Let me not take the same thing. Yeah? Okay. Here say it's 1 1. Here if I put 1 and 0, then what happens? It will become 2 and 0. So 2 and 0 would be somewhere here. So the vector direction changed. So this cannot be the eigenvector. Do not assume that whatever vector you take and here, if it's the same, then problem is solved. No. You also have to look into eigenvalue. So this is eigenvalue and eigenvector. Just remember one thing. The vector, if a vector's direction doesn't change, then that's called as eigenvector. Oh my God, too much of math. Yep. Why did we explain? Why did we understand that? Because we have orthogonal here. Orthogonal plus unit length, meaning if you square and add the values, if it sums up to 1, that's called as unit length. The columns, if you take the columns and do that. Okay, if you have both the features, then it's orthonormal. That's fine. Now let's understand here. Say you have a matrix which is n by n. So say you have n documents and you have n terms, or you have n terms, n documents, however you want to look at it. Then you're going to multiply it with, I mean, you can decompose it. You can decompose it into U sigma V transpose. U is n by R. Sigma is R by R. Can I multiply these two is the first question. And the answer would be obviously yes. Why is that so? Here and here, it's the same. If it's the same, then you can multiply these two. And the resultant of multiplying these two would be n by R. So if you multiply n by R with this, then what happens? Then this and this gets cancelled, and then you get n by n. Which is the same thing as this. So you got back your original matrix. But why do I even need to do that? Let's take a small toy example. Say you have an image. Okay. And you know for a fact that image will have pixels. Pixel intensity values is the most raw form of data. So you have a 4 by 5 matrix. And these will have pixel intensity values. And when it comes to a grayscale image or a black and white image, the pixel intensity values will range from 0 to 255. 0 means black, 255 means white. Even if you have a color image will be in this way, RGB, red, green, blue, majorly. Okay. And if you take out each channel out, it would be a grayscale image. And again, the values range from 0 to 255. 0 means black, 255 means white. If you take out only the green color, again, it will become grayscale with 0 to 255. If you look at only blue color, it's the same. Combination of these three will give you colors. As a standalone color channel, if you look at, it is nothing but a grayscale image only. So all that aside, so those are the pixel values, say you have in your matrix. And you can decompose in this way: U, sigma, V transpose. This matrix is arrived at based on eigen value and eigenvector decomposition. That aside. So what's happening here is you have a matrix which is 4 rows and 5 columns. So it is 4 by 5. How are you getting it? You have U, which is 4 by 4. Okay. You have this diagonal matrix. This diagonal matrix, actually, the way you represent that is R by R. Okay. So it is again 4 by 4. This is N by R. 4 by 4, 4 by 4 can multiply, and then resultant will once again be 4 by 4. Multiply it with this 4 by 5. So the resultant of multiplying these two would be 4 by 4. If you multiply that with this, can you multiply in the first place? Yes, you can. And the resultant would be 4 by 5, which is similar to this. So you can. Hey, what is the fun that we are taking in doing this? Yep, very good question. So the answer is, if you run a k equal to run 1. So this is called as rank 1 approximation. Rank 1 approximation. So you have a 4 by 5 image matrix, which is 20 bytes, 4 into 5. So what you're trying to do is, you're trying to compress the size of the image. You're kind of trying to reduce the dimension. So here, this is a 4 by 1 matrix. Because it's one rank, what you're doing is you're taking the first column from U into, you're taking the first diagonal element, which is of dimension 1 by 1. 1 by 1 is 1. 4 by 1 is here. Plus, you take the first row, which is 1 by 5. 1 row, 1, 2, 3, 4, 5 columns. When you multiply, you get 10 bytes. Wow! We could reduce the dimension of the image from 20 bytes to 10 bytes. But then, would it throw any errors? Yep, sure, it can. It would. So if you look at your original image, it should have been 1 here, but it's 0. If you look at this, it should have been 3. But what is it now? 0. Okay, and then you have 2 here, it is 0. So these are the errors that you get. Here it is 4, here also it is 4. Wonderful. Rest all are good. These 3 are errors. But then, are you okay to live with these errors, given that you could compress the size of the image by 50%? Is a call that you need to take. All right. And here, when I say k equal to 2, it is called as rank 2 approximation. Rank 2 approximation. That means you take the first 2 columns, first 2 diagonal elements, and you take the first 2 rows of U, sigma, V transpose to get the final output, wherein you're getting errors here. But this part, I think, is fine. But then the size of the image is 20 bytes. Original image is also of 20 bytes. So why do you even want to do this? Is a $1 million question. Okay, next. I'll give you a real world example on how this can be implemented. This here. Here we go. Now, this is an image of a person called Lina. She's invited to a lot of machine learning and AI forums because she agreed that her image can be used for image analytics. Yeah. Now, rather than focusing on her, you focus on the concept, guys. Okay. So the original size of the image here is 147,000 bytes, 147 kilobytes. That's the size of the original image. And then if you say k equal to 1, k equal to 10, k equal to 20, 50, so on and so forth, you get the values. When you say k equal to 1, you take the first column, first diagonal element, and the first row, and then the size is significantly less, 769 bytes in comparison to the original image, which is of 147 kilobytes. But then there is nothing in the image which is visible. If your goal is to just detect whether there is human in the image or not, then maybe you might want to increase the k value. If you increase the k value to 10, what happens? The image size increases because you are now interested in taking 10 columns, 10 diagonal elements, and 10 rows. 7690 bytes, which is much, much less than your original image. And the interesting bit is you're also able to make out that there is a human in the image. Now, if you increase, say you also want to know the gender of the person who is there in the image. So you increase the k value. That means you want 20 columns, 20 diagonal elements, and 20 rows. Okay. Then the size became 15,000 bytes, but here it's 147,000 bytes, which is much higher than this. And then you're now able to make out that, hey, this person is a woman, right? Then say your objective is also to know the age of the person. So you increase the k value here once again to 50. That means you want 50 rows, 50 diagonal elements, and 50 columns. And then the size became so much. Now, if you go here and look at k equal to 50, wonderful. You're now even able to make out that this person is of a specific age. You can, yeah, approximately. And then if your objective is to maybe identify a few more features of the image, then maybe you'll say k equal to 100. Even with k equal to 100, the size of your image that you obtained is half of the original size. That's an amazing achievement in terms of compressing the size of the image. And look at what happened when k equal to 100. Everything is crystal clear. Okay. So when you increase it to k equal to 200, doesn't make sense. The size of the image increased, but then maybe it is giving you a few more finer details, but not really needed, maybe, if you ask me. Okay, until unless you're doing some investigation wherein there is a person hidden here who was trying to shoot her. Okay, I mean, I'm just making out stories. I think she's still alive, but then, yeah. This is how you can use SVD for dimension reduction. And how is this related to natural language processing? is something that we will have to discuss in tomorrow's session. Suspense continues. Okay, so this is what we discussed, and we will get here. We will do that tomorrow. It will be completely theory to understand LSI, to understand LDA. You would also understand, you know, the various other concepts of NLP, and then on Saturday and Sunday it'll be completely hands-on. Hope you enjoyed the session. Let me take your uh, you know, questions. Katappa, why did Katappa kill? Okay, let me look at your questions. Okay, huge data sets. Yep, you can think in that way, Shantanu, but it's also used when you have sizable data. It need not necessarily be huge data. Yep, Raushan Kumar, we have live projects on NLP. Would you be interested? I will be happy to accommodate. Okay, I did not get any LMS access for this NLP session. Bharadwaj, no, there won't be NLP session. It'll be there on your YouTube channel. Yeah. The crux of contents, topic modeling. Yes. Okay. Movie script or interview of a person as a whole can be considered as one document, or how can we classify them? Each sentence also you can split it, Shruti. Depends on you. It's completely up to you. You can either assume that each paragraph is one document, or each sentence is a document, or each word can be termed as a document. Each character, alphabet can also be termed. Two words put together can be termed as one document. It's up to you on what analysis you want to do. Okay, you like solving more math? Good. The U, sigma, and V values internal. Yep. They are computed in a specific fashion using mathematics. Yes. Pixels are matrix here. Yes. Yeah, it's there, Arvindas. So I don't know where it's being played now. Can we, Enoch, are you there by any chance? I wish we have Enoch, because we can share previous recorded sessions here. And what do we achieve in NLP by reducing the size? Huge data, Sandesh. And if you go to Google and search for any document, Google will retrieve the data within seconds, right, Sandesh Tiwari? Within seconds, it's going to retrieve the data for you. Okay. And if you want such lightning speed, then you want that compression. You want to reduce the size of the data such that you quickly retrieve the documents for your query and display it. Yeah. So for that purpose, we use it. You'll learn more tomorrow on that. We have covered so many topics, but could you please do let me know the sequential flow of NLP project along with core areas need to be focused? And I can't answer objective, but I can answer. Okay. Yeah. They don't worry too much on that. It's all about, see, data cleansing. And then you perform a pre-processing, you build a model, and building the model is something that can be done using your machine learning algorithms, your supervised learning algorithms, predictive modeling, or using unsupervised learning techniques. Simple. NLP is nothing but I give you natural language, which is in form of newspaper, news articles, blogs, tweets, anything. You just extract meaningful insights from that. That's it. They just extract meaningful insights, nothing more, nothing less. Yeah. How do you extract? Oh, there are a bunch of techniques. All right. And those are the techniques that we are learning. Ultimate objective is bring out meaningful insights from the data. How do you bring it is left up to you. We are giving you a bunch of arms and ammunitions. Which one do you want to use to fight? It's left up to you. All right. We shall now stop and then we will continue tomorrow. Thank you all so much for your time. See you tomorrow, and also on Saturday and Sunday IST morning 7 to 9 a.m. Do attend. Thank you all. Bye.